So, hello everyone. We've got 1 p.m. Here at Council at FOSDEM 2016. And now, soon we'll hear a talk about open sourcing private Atlas from Philip Homburg. So, I think let's go.
This is a quick overview. We'll talk about a lot of introduction on private NCC because I need that later to explain how we deal with open source. Then I have a quick overview of what is private Atlas for people who don't know and some updates for people who know what it is. Then the part about open source and then how it can take part in the life of community. So this talk was proposed by our community builder, FOSDEM, and basically she has to build community, so it's basically sales pitch like, come on, join our community, we have a great community, we have lots of fun stuff. And then it turns out that roughly at the same time, she could also speak at a conference in Kathmandu, and well, an exotic location is of course way better, and I was going to FOSDEM anyhow, so I got to do the talk. But then when I looked at the title, I thought, yeah, but I know other interesting stories to tell about open source, and not just on every depot people. Of course, we need depot people, it's a very fun project, but there's more. I think that's also interesting for this community. So I left her make the slides, and at some point I will just start telling a completely different story to see how that goes. So the introduction to RIPE. RIPE was started in 1989, and what happened in that time is that people got operating systems with a TCP/IP stack and didn't really know what this internet thing was. So there wasn't really much internet in Europe. In the time, I think there was some military sites of connection in England, nothing else. Just last week, I saw a comment that at CERN, the Particle Physics Institute, they had to renumber from 1.000/8 because they were copying some documentation. I thought, well, this is a nice range of addresses to start with, and then they found out you shouldn't really do that. And there was a guy in the US, Joe Postal, coordinating that, and then you have probably also a language issue that people don't speak English and they don't want to talk or request stuff from their language. So some people came together and said, well, we have to coordinate that because if you build a European network, then it's really important that everybody uses different IP addresses. And that they found it right. And basically, the goal of RIPE is collect needs for IP addresses in Europe and then go to Joe Postal in the US, later in Indiana, and say, well, we need these many addresses. That went on for a while, but if you have administration and for a while and it's small, somebody can do that next to another job, but at some point you have to start hiring people, and then the RIPE NCC was founded, and basically if you need resources, then you have to pay for the administration of resources. And that led to the structure that we still have today, and that is RIPE is extremely open community that there's no formal membership. Just sign up for a mailing list and join in discussing policy. But if you actually want to benefit from what policy, then you have to pay the RIPE NCC who do the administration of that. And RIPE NCC is again very much founded in the community because all the RIPE NCC members vote on the activities of the RIPE NCC, they vote on the budget, and they also appoint a board. Then RIPE was the first instance of this sort of regional internet registry, and then over time we now have 5 of them showing in this image. And the interesting thing to note here is that every also do other stuff. And for example, we run one of the root TLS instances, so it's K-root. But we also started doing measuring and monitoring projects. Like we have a BGP monitoring project called LIS. We collect the BGP routing updates worldwide. And you can see, well, if I announce that it's here, does actually the rest of the world see it, or does somebody block that? And we also started measuring data, first with a system called DGM, that around, say, 100 nodes, and that later became private public. So that's sort of who we are. Then, about others, we have managed to sneak in a Wikipedia page. So if you want to enhance that, I mean, officially we should not write our own Wikipedia pages, so that's something the community should do. There you can read about it. Basically, we measure whether the internet is broken or not. We discovered lots of small probes, and we have, I don't know, how we get it out more than 10,000. Usually we get it out how many are up simultaneously, and they do a number of measurements that they always do, but users of the system can also come up with measurements. So if you have a website here and you want to know whether it's reachable from Latin America or not, then you select some probes in Latin America and let them connect to your website, and then you can see does it work or not. And then here on the right hand side column, there's some statistics on where probes are. Recently also due to some sponsoring, we now have a lot of probes in the US, but because we're based basically in Europe, still we have really lot of probes in Europe, and in some other regions it's also really hard to get probes there. So here's some statistics, like the more than 9,000 active probes at the moment, with lots of users. At some point we came up with a concept called anchors. An anchor is a direct mount PC, or low end PC, but it's way more capable probe, so we can run way more measurements on it. But we also run some basic services on the anchor, like the DNS server that has some static answers and the web server and all. So you can also do measurements towards the anchors, such that you can verify the reachability towards a certain region of the world. And some statistics that are not here, but you can be interested, is that at the moment we collect roughly 3,500 results per second. So it's an enormous stream of results. We have also roughly, say, 10,000 different measurements on the system. And some of them are run by us, but many of them are also run by the various users of the system. Top thing is measurement types we support. We have the normal penetration route. We can, basically almost any kind of DNS measurement. For instance, a couple of days we can also do TLSA records. We have a basic SSL thing where we can fetch the certificate, but we don't do anything more. If we want to do full TLS, we haven't done that yet. You can do entity measurements, and because of the risks of telling probes in the around to go to, say, Facebook, we limit HTTP to only use anchors as targets to avoid police showing up at the door of the probe. We have a website where you can do everything, but we also have a full set of APIs to start measurements and results. All kinds of visualizations on the website, you can check it out. We started creating a sort of command-line tools where instead of saying ping, you would say Atlas ping, and then basically it would behave more or less like ping. It would schedule a measurement on Atlas, collect the results, and show it also in a similar way that you get for DNS 5 answers. So that's different from DNS. One thing that is really cool is the streaming. So we have now a live feed of all the measurements as they come in, and you can say, well, I want to listen to this particular measurement, or I want to have all trace routes, or some filter characteristics. But basically, you can just watch results as they come in. You don't have to fetch them all. You just set up the stream. And then we had some new visualizations or cool sets like time travel is where if you make a graph of ping results, then you can just select I want to see results in, I don't know, September last year or not. Latency 1 is an attempt to make the visualizations more intelligent, so it tries to sort of compute a baseline and then show how it deviates from the baseline, instead that you have stuff that is highly predicted for where you don't see the details. And domain 1, we for a long time we had a service called DNS-MOL, and DNS-MOL is basically where we monitor whether your DNS song works, but that was essentially sort of defined only for the big guys. So if you were, we would monitor the root zone, and we would monitor some of the countries, certainly in the Rhine region and some other stuff, but that was certainly not available for ordinary people. But originally the main mode used a different platform, the DNS mode used a different platform that was related to use Atlas. And then, because basically DNS mode is doing measurements and visualization, we said, well, if Atlas user will schedule his own DNS measurements, and we can give the user the visualizations that we already built, and we built some also web parts where you can configure it, so you can now monitor your own domain, and you get a nice visualization of which probes could reach which of your name servers. Okay, so that's a short introduction of what Atlas is, what it does, a big collection of probes. There's a backend system that stores results, websites, APIs, and stuff like that. So what about others? So here, we pitch through that because, well, I took Vesna's slides and Vesna wanted to talk about something else. So she says all the data is open, that's true. So we have now, I don't know the exact number, maybe say 100 terabytes of data, or I don't know the hundreds. And you can just have it. If you actually want to have 100 terabytes of data, maybe you want to talk to us how you get that. But for anything else, I mean, you select what you want to have, you start downloading, and if you find out that there are issues, well, talk to us, because all the results that we collect, they are available. We're not trying to hold them back in any way whatsoever. Coming to the source code. So what happened was, this is a first generation probe, and we were handing out these things and said, well, put them in your network, it's cool. And well, people did that. And so when I joined the project, I joined it was maybe a year old or something like that. There were a couple of hundred probes in the field, and the software that was running all the probes was really of quality. I don't know if it was even. And probes were constantly rebooting, and it was all not very nice and whatnot. So there was a lot of work to be done to make this a reliable measurement platform. And the code was based on using Linux, which makes really not very capable processors. And then they started off with BusyBox, and you take ping and trace route, and you modify it a bit such that you can have it all in one line, and then you send the line to our backend system. And so we started modifying that, making those tools better, and make them report in JSON, and make them use the event and all. But it was still using Linux basic box. So you give the probe to somebody, and there was found to be some people who say, even if they don't know what it is, can I have the source code? And then we said no. And that was a bit weird, because this is TPL. So how can you say no? And so I have to admit, I mean, I always like the BSD license way more than I like the TPL, so I'm not really into, we have to advance free software, but I still think you have to show respect for licenses. You can't just take TPL code and make things proprietary. But that's exactly what happened. And then it's, well, can you do that? Well, if you look at that from a legal point of view and say, from history, then yes, you can do it. Nobody ever complained. We didn't get sued or whatnot, didn't even make a use. So in that sense, yes, sometimes you can just violate the licensing code, and we say all realize and open and whatnot, and still people didn't question it that hard. So I thought also personally that's also is actually ethical. You work on such a project. So there, what happened was that I was for a long time interested in law, like what does copyright law really look like, what was the TPL really say, what court cases say, and then when I was thinking about this for a while, I thought, okay, I know a nice legal loophole. Oh, cool. So now it's perfectly legal what you do, I don't have to worry. So we went on for maybe a couple of years. That were expanded tremendously, and the reason, well, I don't know, I'm not management, so I don't know really all the reasons of management. But one of the reasons I had earlier is that suppose we release the source code, then some commercial company comes, and there are commercial companies doing all kinds of monitoring. They take our source, spend, I don't know, a couple of $100,000 or more by a huge number of probes, sit probes all over the world, and then there's a big measurement network, really small measurement, and then we're dead, because there's then a commercial network, and we want to have an open one. So that was sort of, we have to keep the source. I mean, we cannot afford to have people just starting a competing network based on license. And then a couple of years later, I guess there was also some pressure, but also, okay, now our network is big enough that we can afford to release the source because no competitor will show up. There's enough support in the community that it's safe to do that. Okay, that's nice. So now that, well, at least certainly I have a different problem. We have measurement code, which is just big C, and it's sometimes relatively complex C, and we have two people writing the source, the code, one of them, and we essentially don't do any review. So, well, we try to write our code as well as we can. But it's still, I mean, it will be public-facing network code written in C, and we're going to just release that. What if there's security problems? This is sort of scary. And then to make the situation worse is that we have two natural moments to do anything because we organize two conferences per year. And we were going to release it at conference, and right at that time, I had already a vacation planned, so I wouldn't even be there. Maybe we didn't even have an internet connection or not. So we released the code soon, so maybe a couple of days later or so. We get somebody said security report and said, well, you have the following 5 or I don't know how many issues. Oh shit. And it turned out that was a misunderstood context in which the code runs. All of the issues he found were something that were not remotely exploitable. You could exploit them if you were root on the probe. Yeah, if it were already root on the probe, that's not much to exploit it. So that went really well, and sort of nobody found ever any security problems in our codes by looking at source code, so that in that respect it was perfectly safe to do. There are people coming up with creative inputs and that triggers it. So it's not completely safe. But then we got another problem. And that is, we naively assume that, okay, we have this really great code base, and we have all those open source programmers, so somebody is going to write enhancements, new measurement types and whatnot, so they just run the code on their Linux systems and they write, I don't know, well, we still don't have TLS measurements. And then we get a pull request with a huge change, and then it has to run all these things, which is basically the Commodore Amiga on steroids. This is 8 megabytes of memory, 16 megabytes of flash. It's 68,000 without an MMU, so any power point to store is completely variable. And well, it's clocked a bit higher. These things are clocked at about 30 megahertz. It's a bit higher than the original Amiga. So we thought about it. We thought, yeah, we don't really want those kind of pull requests. If we have to integrate code, then we want to know before what somebody's going to do, and we want, if the code quality is too bad, then we would have to rewrite it anyhow, so it doesn't make sense. So what we did is we only release star files. Well, we don't, at least we don't put it on GitHub, I think somebody did. This is now a weird URL. Because I thought, well, I'll get to that later. And that part also worked, because now we have the situation that as far as I know, nobody uses the code. Which is also, in some sense, it's really sad, because if you want to measure something, you want to do some bits or some threshold, I think it's a really nice code base. For example, you get out of the JSON, I mean, you don't have to sort of screen scrape the output of threshold to figure out what it does. It's lit event, so with very little resources, you can do a huge number of parallel thresholds and whatnot. So I encourage everybody to take a look at it, play with it, use it for whatever you want to measure. And enhance it, but if you think, okay, I also want to run my changes, want them to run Atlas, then please first approach me before you start doing any development. And we have cases where researchers said, okay, I have this really nice code base, please run it all on Atlas, but at least they didn't do any work yet, because the sources are all. Please integrate. Didn't really happen. So that's the probe source code. Now, at that stage, we have probe source code, and we have on the probe we have also lots of shell scripts. For some reason, nobody is ever interested in the shell scripts, so that was released. And I guess we clearly released it, but what's the point? And then we have a large amount of code that talks to probes, to send out measurement requests, to collect results, store that in Hadoop, do websites, we all have lots of stuff. That's all also not released. And there we also sort of have, again, the problem with the competitor, except now on a small scale, that there are some companies that say, can we have our own Atlas, and then we can internally monitor our data. And then we are worried if people set up their own Atlas systems, does that cause enough fragmentation that there's no global view anymore? That the whole point of the system is that you can see everything, that everybody has their own instance of Atlas, and it doesn't work anymore. Other thing is, it's really large code base, really complex, many different servers and whatnot. So it's also not clear if you could ever write an installation manual for it. So moving on, we're well, relatively happy. We have a project that works well and whatnot. But we have a community of network operators, and we want them to use it, and we want to use that Atlas in sort of the day-to-day routine, which means that we want them to integrate it in their monitoring system, we want to use it from command line and whatnot, which means that they're probably going to write some small scripts around our APIs. And then we want to encourage them to share those scripts, of course. And then we get the issue, like say somebody writes a quick and dirty Perl script that does something and it does it for 90%, there's some corner cases that are missed. Should we then publish this script and say, this is a cool script? Because what happens if then people come back to us and say, the script doesn't work, please fix. Are we supposed to take over the maintenance of those scripts? And certainly, I mean, if we only do basically Python, should we take on the maintenance of Perl scripts or what? So then what happens, what we came up with is Private Atlas community GitHub. And basically, this is stuffed up by the community. Anybody can contribute. The people with commit rights are people from the community. And if it doesn't work, it's not our problem. We only coordinate that it's shared, but we don't say anything about the code. And so that works very really well. For example, there's a French guy working for the French FR domain, who publishes all kinds of nice scripts with monitoring and whatnot. And he's also one of the community members that accepts pull requests and commits it. And then, and because of this, we don't give any guarantees. What we did, we organized some hackathons, and the results of those hackathons are also freely shared. Anybody can download all of the data, so the visualizations that were created in the first hackathon, everybody can use that, everybody can play with that code. We don't give any guarantees. And then for one of the visualizations, we implemented our own version that we will use on the website, but that's just completely different companies. And then we got into another new situation. One of our programmers wrote Cousteau, which is a very simple library to create, to use the Atlas API, and that was mostly dormant for a long time. We used it internally a bit, nobody really picked that up. And then what happened with sort of unique situation in that is we store lots of old measurement results, and we have the policy that we store measurement results as they came in at the time. And that means that if you change your measurement output to formatting, then you can have different formats, or maybe there were bugs and whatnot. And what we do is we tag all the measurement results with the probe firmware of the probe that the probe was running when it generated that result, and we try to document all those different versions and whatnot, so that if you get the results, you can look up what was it supposed to be, and weird situations. But then if you look at it as a programmer, then people were again and again writing parsers for the measurement results, like as if it's called that firmware, this field is called that, and then if it's that firmware, that is called something else. And at some point, that just doesn't work anymore. So then that guy in the white was at that time working for us. Started writing Sagan, and Sagan is a Python library that can take all those results and you can present them in a uniform way. So you use his library and you just ask for this property, and well, if it's not there, you probably get none, but if it's there and it has a different name in the past, then you still get it. And that was, of course, very useful internally, but it is also very useful for anybody who wants to use our project for his own scripts. But the thing is, because we use that library internally, we couldn't just put it on the community GitHub and accept any pull requests. So we have to make sure that we have a different GitHub repo, essentially, that's strictly controlled by us. And everybody can still submit pull requests. We want to make sure that we very strictly vet it, make sure that it really works, because the next slide we deployed, and we also deployed on our own website. So now we have sort of basically 3 different ways in which we do open source with open source code, where, well, it's there. We don't do anything with the community. But the community GitHub, which is, well, essentially the bazaar in front of the cathedral that we are building up. Then, due to popular requests, we started creating a command line interface. I mentioned that already. Like you want to do unpass ping and then some target, and then you get results back for probes. So that's there. That's also released in sort of the controlled way, like the accept contributions, because we do want to vet them. And then, because we want operators to be able to access them easily, we also asked people associated with various distributions to add that as a package. And you see here there's a list of all the BSD, BCJ, and artists that did that. And there's a couple in progress, but if any distribution wants to add it, then get in touch. Or just do it. Moving on. So now, so it was sort of what I wanted to say about what we did about open source, all the different types of open source. Now we're moving on to a project that is also completely open, so very interesting. And that is that if you have an IP address and you want to do a trace route, then you want to put the trace route on the map, because well, you sort of want to know where your packets go. And for say consumer IP addresses, they're mapped pretty accurately, because usually it's all kinds of vendors that want to know where somebody really lives. That makes sense. Some multimedia, you want to know whether somebody from this country can visit, watch that or whatnot. But then for the core internet infrastructure that doesn't exist, nobody really cared about that. And there's every network operator sort of does something on its own. And of course some people set up projects that went nowhere. So this is our attempt to try to map all of the routers on the internet. And we try to do it just like OpenStreetMap, like everybody who knows from a router where it is can just update this IP is there. Showing an example here. So you see here a number of trace routes, because typically if you use Atlas, then you get a number of probes, so almost always you have a number of trace routes. You have a solid line here. I think that in this user interface, that's the one so that is highlighted, that's the one you currently selected. And then you have the green one. I think that's where people explicitly set geolocation, and then there's the white ones, and that is where the system tries to infer it, for example, from the reverse DNS name of the thing, because in many cases operators encode either place names or airport codes or whatnot, so you try to guess that kind of stuff. And if you look at some trace route and you see, okay, this is really weird, why is it coded? And then you click on the link on the dots for that router, and it's, it mistakenly thinks that this router is in, say, the US, but it's actually in Europe. You can update the entry and say, this, yeah. So if anybody wants to contribute to that project, get in touch, go ahead. It's also the source code probably use updating, or at least if people want to use it in other things, then they want to make interfaces with the database, etc. This data is also used in an interesting way. So now this is for the use case of Atlas, and that is if you look at the ISPs in a country, then you can ask the question: if you send a packet from one ISP to another, does that leave the country? I mean, in some cases, when you think about government spying, then you want to make sure that the traffic doesn't go through the country that you don't like. And you can also try to figure out if there is an internet exchange in the country, does it go through the internet exchange or not? If it goes through one. And also here, if it's leaving the country, then you have to have some idea where routers are. Otherwise, you don't know if it's leaving the country. So this uses that router geolocation information to say, okay, this went to a router that we know was in a different country. Well, here's a nice list of how you can get involved if you want to. So if you're a researcher, if you want to do measurements with Atlas, then we have a credit system. And typically, if you have a probe installed somewhere, then you get credits for each day that the probe is connected. If you are a member of the IPCC, then you get credits. There can be all other reasons you get credits, but also if you have a plan for scientific research, you plan to publish it, and you need credits, then that's also just come and ask us, tell us what you want to do, and then if you like it, then you get, well, almost unlimited credits. Well, there's the code. For example, with code that displays results, all the results, like I said, are completely public. So if you want to play with that, if you want to look at, say, trace routes all over the world, you can just start downloading it. You can look at the code to see if you can improve them, if you can come up with better ways to visualize, say, trace routes or whatnot. We organize webinars to explain how to best use Atlas. We came up with an ambassador concept, and basically ambassadors get a collection of probes that they can distribute in their own circles. Which is something so that we have to do for, say, countries like in Africa or many countries in Asia. You cannot just send a bunch of probes off the mail to those countries because they probably don't arrive. So if you want to do that, and if you regularly travel to countries where we don't have a lot of probes, but in Dutch, and of course we can always use sponsors. If you care enough about Atlas, care about sort of the quality of the results, then you can also host an Atlas anchor. Advantage of anchors is you get 10 times more credits. Disadvantage is you have to buy the hardware yourself. Apart from that, we do all the maintenance, so it's just a one-time cost of buying some hardware, installing it in your rack, and it starts working. Well, if you visit exotic locations, I can place a probe there. The probes, I also brought a small number of probes. Look at the map and see if there are exotic places. And we have more hackathons. So if you want to, if you're interested in network data and you want to write tools for that or whatnot, different places to go to also cooperate with network operators and see what you can create. Then we have promotion for, this is research oriented, but yeah, if you're a researcher and you want to present results at the right meeting, then we have a program for that. And then extra contact information. And basically, if you have questions right now, ask me, and otherwise, probably best to send questions to FOSDEM.
So, are there any questions? We've got, Susan's, there's any questions? Someone waiting, please, I don't see you.
Hi, any sorts of converting a development board like Raspberry Pi or something like that to okay, it's again okay. Any sorts of supporting development boards like Raspberry Pi or something like that, converting them via screen or something like that to an Atlas Pro? Okay.
So the code, the message of code that we released is just compiles under Linux. So if you want to run that on a Pi, that's perfectly fine. The thing to remember is that for Atlas Pro, you also need key material, and we install the key material on the probe when we install the program. So you can use the measurement results, but you cannot participate in the Atlas measurement network.
Okay, thank you.
Hi, this is Paul. I just want to say that all the Atlas packages are currently in Fedora to be tested, so you can find the review box if you're interested in the package. But we still need to just get them through review and get it published.
Anyone else? More questions? Anyone? Waiting there, first row. Just a second.
It's not a question because I used to work there, but maybe it's more of a comment. When we decided to open source some of those tools, there was some pushback from management. People were afraid; they weren't sure what was going to happen. And for those of the people in this room who may be on management, I can tell you it was awesome. People write code for you for free, and awesome. Not necessarily great code a lot of times. Sometimes the code's not awesome. But what happens is you look at the code and you realize this is what your users want your code to do. You accept the pull request, you tweak it, and now everybody's happy. They get a better tool, and your tool gets used more often. So, yeah, not something that's nice to be sold at FOSDEM or very much.
There's someone waving. I see them.
So you mentioned you would like probes in exotic parts of the world. Where are you particularly short? Where would you like probes that you don't have lots?
On our website, I hope it's not too cleverly hidden. There's a link that you can click to register to apply for a probe, and you fill in the location where you book it. We also now have complex formula based on Fibonacci to compute how many probes we want to have in a particular AS. So we try to figure out what is the size of an AS, and if it's a really big ISP, then we want to have more probes there than if it's a hobby AS. So it's also possible that even if there are already quite a few probes in an AS, that we still want more probes there. But yeah, I don't remember the formula by heart. So yeah, if you think I want to probe somewhere, just go to the website, register, and say, oh, it's there and there, and possibly in this AS, but usually detect that from the IP address that you contact with when you try to register.
May I come up to someone who wants to make a question? Any more questions? I don't see anyone waving at me. So, maybe let's presume all questions are answered that we're so far here. Thank you very much for the talk. And maybe some applause.